Hello, I'm Greg. Welcome to my channel, Midnight Oil Software, and another devlog for my real-time, cross-platform multiplayer card game, Highland Panic. Highland Panic is a fast-paced card game with the mechanics of solitaire, where you race to be the first player to play all the cards from your panic pile to a common clan pile. And what I'm going to show you in this video, I want to show you the refactoring that I've done and how I use the Unity lobby service. So the Unity lobby service is what you would use to create games, add and remove players to games, join other players' games, set game parameters, and so forth and so on. So I'll demonstrate that here. I'll create a game. I will add a bot. I will adjust the bot's skill level. I'll go ahead and kick the player from this game. Maybe I'll leave this game and I'll join another player's game. So we have another player creating a game in a different session. That'll show up here in my list. And then I can click join. So that's basically the lobby system, how it works. Let me show you the code in here and what I'm going to do to refactor this. So why am I refactoring the code? Well, there's a number of reasons. For one thing, the Unity lobby service throttles request so that you can't exceed certain rate limits. So here on the documentation page for the Unity lobby service, you can see that each type of request has a rate limit for how many requests per second and so forth. And the way I initially coded this is the way I often do when I am working on a game. I first just try to get the gameplay working and make sure that my idea is fun and that my design is sound. But I'm not really worried about optimizing things initially or writing the cleanest code. So what I want to do usually is just get it working and then go back and refactor to clean it up and enforce things like the dry principle. You don't want to repeat yourself. So dry is don't repeat yourself. And you'll notice when I show you the old code that I've got a lot of duplicated, maybe not exactly copy and pasted code, but definitely the same pattern repeated over and over again, like the way I handle exception handling and stuff like that for each request, the way I handle the retry logic, the way that I enforce the rate limits. Essentially the way I'm enforcing the rate limits now in the old code is I just catch the rate limit exception if I tried too many requests, and then I just retry until it succeeds, which is not the most efficient thing you want to do. For one thing, it's just wasteful to throw exceptions unnecessarily when you can prevent them. But the other thing is I use a service called backtrace, which will log any exceptions that my game throws out in the wild, so I can actually see what kind of errors users are running into and address them even before they log a bug report. And I don't want to clog that backtrace log up with a bunch of unnecessary exceptions, which aren't really bugs. They're just rate limit exceptions because I'm making too many requests. So let's first look at the old code. So this is before my refactoring. This is a class called lobby service, and lobby service has a bunch of calls to interact with the Unity lobby service. So this function here, gather lobbies, is going to issue a query lobbies async call to the lobby service. And then I'm wrapping that in an exception handler here. Here's one to create a lobby that's going to build basically the options for that create lobby operation. It's going to make the async call create lobby async. Again, it's wrapped in a try catch block. If that succeeds, you'll notice I'm waiting for that operation to complete, saving the result off to my current lobby variable. I'm setting the host relay to use the relay port that I set up. And then I'm firing off an async function to periodically send a heartbeat to keep the lobby alive, and also to periodically request the latest data for that lobby in case more players joined or metadata was changed, like the skill level for a bot and so forth and so on. So you're going to see how that changes with my new implementation. No longer will this guy sit around and wait for that operation to complete and then use the data it gets. It's going to fire and forget, and I'm going to subscribe to events for when the operation completes. But I'm getting the cart ahead of the horse. Let me show you a little bit more about the old code. This is an update lobby function. Again, it's wrapped in a try catch block, and it's an async method that's waiting for that operation to complete. Same thing here. If I'm joining a lobby, If I'm adding a bot player, that's going to be an update method because I'm adding it as metadata to the lobby. You get the idea. Down at the bottom of this class, I've got my functions to send a heartbeat. So there's a heartbeat request, and this is a refresh, or actually a get request, to get the data for a specified lobby. So I can make sure that my list of games or my game data that I'm displaying locally matches what the lobby service has. So how did I refactor this? Well, let me start off by showing you something called the Lobby Operation Manager class. This is a new class that I created that's going to allow me to queue up operations. So I've got this list here. Lobbies execution queue is a list of lobbies operation base. So lobbies operation base is an abstract base class. It's got an operation type. So we go look at that. That's just an enumeration. It's an integer from 0 to however many operations there are. And I'm going to use this integer value to index into an array for handling the retry or the rate limit stuff. I'll show you that later. It's going to keep track of how many times I've attempted this particular operation, so I can know if I've exceeded my retry count. And it has an abstract execute method. And the execute method is async, and it will return a lobby's operation result. Lobby's operation result will return the operation type, a list of lobbies. So if this is a query operation, it will have the list of operations, list of queries, list of lobbies returned by the query. A Boolean that says whether or not the operation was successful, an optional message, might be an error message, might be some other informational message, a dictionary of optional metadata that might be relevant to the request, a function to get the metadata by key, and then basically in my constructor for this lobby's operation result, I want to initialize my list of lobbies and my metadata dictionary. So going back to the lobby's operation manager, we have this public function in queue lobby's operation. So in my lobby service, instead of calling an async method, well, that's the result. I'm going to show you this later. This is what I get when the operation completes. This is an event that I subscribe to, and I handle the result of the operation here. I'll get to that later. First thing I want to show you is how instead of doing an await on a particular operation and wrapping this in a try catch block, I'm just enqueuing the operation. It's fire and forget. This is no longer async. I just fire, forget, and then the calling function can go on with its life. And the calling function will subscribe to one of these public events up here, and then that will get handled here. So for instance, the query, all I'm going to do is fire a lobbies refreshed event to let them know, hey, my lobbies were refreshed, and here's the list of lobbies that I got back. So no longer waiting around for that operation to complete. It's just going to handle it through an event pattern, a pub sub pattern. Same thing for create. If I create a lobby, the result will fire a game refreshed event. It's going to start my heartbeat and my periodically refresh lobby. So again, instead of waiting around for that operation to complete, I just enqueue an event, wait for it to wait to get a notification via event that it completed and didn't do this work. Same thing for joining a lobby, updating a lobby, and there's different types of things I can do when I update a lobby. So I did put some extra logic in here to say, hey, is there a bot player ID in the metadata for that operation? If there is, then I want to set my empty bot slot with that player ID. And then, of course, I just pass that event on to anybody that might be subscribing and be interested in that information. Deleting or leaving a lobby, I want to close out my lobby. I want to shut down my Singleton Network Manager instance. Basically disconnecting if I was connected or shutting it down if I was the host. This is how I remove a player. When I get the notification that it's complete, I again do a game refreshed event so that anybody subscribing can remove that from their list of players and so forth. So it really simplifies the logic in this class. You can see all these guys, they're basically just enqueuing an operation. They're not having to do a bunch of try catch logic in here. There's not a bunch of retry logic in here. it's all handled in that lobby's operation manager. One thing I wanted to show you was some of the lobby's operation classes. So this lobby's operation base is implemented by a number of derived classes. So you see here's a delete one. Basically, its constructor is going to initialize some things that it needs for the call to the lobby service. But the main thing is I build my request, or I take the request that was in queued, and then I issue the actual lobby operation. And this is the execute method. So every derived class is going to override this execute method, and I'm going to keep track of how many times I've attempted this. And so in this case, I'm calling the delete lobby async. It's wrapped in a try catch, so I can either return a success result or an error result, just depending on whether it succeeded or not. And so back here in the lobby's operation manager in the execute method, I'm basically just taking the list of operations and converting them to an array so I can iterate through them. And I'm doing it this way because I'm going to be modifying this collection, and you don't want to be iterating over a collection that you're modifying. So I just get this into a separate array called operations to execute. Above that, if I don't have any operations, I'm just going to delay for 100 milliseconds and continue. So this loop here, this async method, execute operations, which is called from the awake method, it's basically going to execute forever. Actually, it's called from on enable. It's going to execute forever until this execute operations flag is set to false. So on disable, I'll set that to false. So I'm not sitting here trying to execute operations after I've left the lobby. So in here, if I don't have any operations to execute, I delay for 100 milliseconds and just continue in the loop. Otherwise, I get the list of operations to execute. I check the current time. And by the way, I'm using something called time.realTime since startup. And the reason I'm using this instead of time.time is because in an async method like this, time.time will not update. It will be whatever value it was on the frame when this async operation was executed. So in this case, you want to use real time since startup. And you might run into that issue with coroutines too. So that's just something to be aware of. I get the next operation time for that type of operation. So you remember operation type is just an enum, and I'm taking the integer value of that enum to index into my next operation time array, which was initialized in the awake method. And the other thing that I do in here, let me just show you that initialization. I instantiate the array. I iterate through all of the operation types, and I assign 0 to the next operation time. So the very first time that I come in here, I'm going to immediately execute an operation of that type. And then I'm going to reset that operation time for the next iteration. And I'm using an extension method here. So I'm passing in the lobby operation base for the type of operation. This extension method is going to do the new C# switch expression syntax to set the delay for that type of operation. So basically for a query, it's 1 second with a little bit of buffer. For a create, it's 3 seconds with a little bit of buffer, and so forth. So if we come back into here, I'm taking real time since startup, adding that delay and assigning it to that index in the array for that type of operation. So reset next operation time. Then I'm going to call the overridden execute method for that operation. And then I'm waiting for that to complete. So when that completes, I fire the on operation complete event, passing in the result. Then if it was successful, or if I've exceeded the maximum number of execution attempts, I remove that operation from my queue because I don't want to keep trying a failing thing over and over again. And also once it completes, I'm going to remove it from the queue so I don't try it again. So that is pretty much it for the lobby operations manager. So hopefully you found that useful. And if you did, do me a favor and click that like and subscribe button. And I wanted to just mention one more thing. I know I'm going into a lot of detail for something that some developers might find very, very simple. In fact, somebody remarked on one of my most recent videos, wow, so much work for something so simple. And I mean, they have a point. For the stuff that I was demonstrating in my tutorial, it really is pretty simple. But one thing to keep in mind, something that's simple for me or him that's, been doing Unity development for years, is not so simple for somebody just starting out. So I like to really be as thorough as possible in my tutorials and explain why I'm doing things. And the other thing I like to do is I don't just want to demonstrate how to do something in Unity, but I want to show kind of best practices. Like don't violate the drive principle. Try and adhere to the single responsibility pattern. You want to have loosely coupled code by using events and abstractions. You want to favor composition over inheritance, that sort of thing. And so my tutorials might get a little bit long and a little detailed. And I really am doing a lot of work for something really simple, but there's a method to my madness. By the way, if you haven't already done it, be sure to jump over to my Steam page and wishlist Highland Panic. And I'm really also interested in playtesters for Highland Panic. So you can playtest the Steam version by going to the Steam page and grabbing the playtest version. You can playtest the Apple iPhone version. Put a link in the description for the test flight build there. And you can also join my beta program on Google Play if you want to test the Android version. I'm really interested in particular in how the data sync is working for multiplayer games. I think the gameplay is pretty solid when just playing against bots, but I need more play testing around multiplayer games with other people, and especially mixed games with other people and bots in the same game. So yeah, if you want to play test that and give me any feedback, the best way to do that would be to go to my Discord server. And again, I will put a link in the description for my Discord server. So join over there, leave any feedback, especially any bug reports, but also anything that you think would make the game more fun, easier to understand, and just better looking, whatever. Any feedback you have, I'm interested. So I think that about wraps it up for this video. Thanks so much for watching and good luck on your game development journey.